everyone, welcome to Dcademy. So this is chemistry class for class 12. Now, in the previous class, we have already discussed about the electrochemistry and we have come to the point of the discussion regarding the electric potential and cell representation. Cell representation, power ko ninagre ko electric potential di maram nasu phasana kupthana ninagre. So let's come to the cell potential, as I have already told in the last class that we will again remind the cell representation. Cell representation habasi kamai na tawgi habado amukhanna so let's see again what happens here. So koina mamang tawgiba matanda cell representation tawba matanda piramiba reaction do overall reaction organic high reaction do dagi half cell reaction deduce tawdani ko puthokani half cell reaction se puthoba matungda we are going to identify which will undergo reduction, which will undergo oxidation. Oxidation half cell, reduction half cell. Adu khanga matungda we are going to classify them as the anode side and the cathode side. Anode side singsina left the legani, cathode side na right the legani hagreba. Such that E cell do calculate the matamda akune kai high E right minus E left. That means cathode minus anode organin. Here we go. In this reaction, we see copper plus 2 Ag plus will form copper 2 plus iron and what? 2 Ag. Adu idagadi mabhanagi cell half cell reaction se pagpunna iminasi ko. Yengsi. So previous class ta tawgibadu remind tawo oina copper solid plus 2 Ag plus aqueous will give a copper 2 plus iron aqueous plus Ag solid. Yari ko. Sumaila eh. Adu idagadi. From this reaction, we are going to decide which type of element is undergoing oxidation and which element is undergoing reduction. Sige reaction sidagi ko kangi. Sige po se. Asi form to wakanda 2 electron loss tawi ko. Dagi sige po na asi. Let's say sige po dagi si form to matamda electron ani gain tawi ko. Gain 2 electron. Yarba. Adu adadi. Let's say half cell reaction ani tho kaniba. Kay hai loss po tawragadi. Oxidation ni. Gain po tawragadi reduction ni. Chumeka oxidation khange reduction khange. Now let's represent half cell reaction. See the representative the overall niko. It is overall reaction. Now we are going to separate into half cell reaction. Half cell the hydroxy. Half cell reaction matamda one will be the oxidation half cell, another one will be the reduction half cell. Yang asi ko half cell reaction. So half cell reaction the first let's say oxidation half cell ni. For oxidation half cell, which will undergo this oxidation kanano chali sa copper na tra copper se lost electron to ini 2 electron lost away. Adu this my irasi ko copper solid aeropire. Then it will form copper 2 plus kanano 2 electron ko. Electron ani maga si kay hay no copper se electron ani lost away aduga masi copper ion form to away hani. Then what about this reduction? Reduction to matamde kay ani sida silver le yamna tra silver se ionic form ni. Ionic form se kay change to no metallic form da or atomic form da. Yare ko 2 Ag plus kay high aqueous. Now this si po se kay no aqueous on kadawa. Ka sida yarn baba 2 electron will be transferred here. doidi plus 2 electron laure then kai form to ba sigi pots it will form Ag doidi it will form Ag yes that means solid form to have sige ani se like rabani na half cell ani se khange ko half cell ani se khange adoidi cell representation cell representation kai hai anode electrolyte anode electrolyte si laurani then marak ta kana lai de ba salt bridge si po che salt bridge ni hai salt bridge yare ko si salt bridge ne kana samjhan do se reduction half cell yare ko reduction half cell dudi kana warani cathode electrolyte cathode and cathode electrolyte adudi hojik ke hare anode and anode electrolyte dudi kana no hojik mathak de yemu kana you can see here cathode anode so the oxidation se anode to thokba reduction se cathode to thokba adu idi kai orani hojik ye ka cell representation ta umatan de anode habani anode is silver let it go silver electrolyte Ag plus or let's say another oxidation thobani copper natra today copper so it will be copper Cu plus 2 plus then salt bridge anode Ag plus do kana ba Ag sigi mathaki representation sini ko i se adubu kamai i gani khoina sumaine i kya gatra yade kamai i ni representation lakpa matamdadi we will write like copper modulus ke dada machingani ko then copper 2 plus similarly mabani khaidok pari single ama khanga khaidok kani ko si khai si kai no electrode ka electrolyte ka ani sigi marakta kai lehaba EMF lay hai ko that means electropotential lay hai ja adu lay habu le sina yai ko then ani se salt bridge se samjil hai ja cathode ke anode ka se aduna sida representation na magi electropotential lay jabaduga amagi electropotential lay jabaduga salt bridge ne samjil have to tak na bagi ko similar ko next we are going to write Ag plus Ag yare ko so this sigi pull up se jibo khone kai ko ba cell representation yare ni ko so si ba bani mamang da khoin tai se so sigi matung tarakpada next we come to our slide ppt dang la si ko so similarly that means electropotential kai no have a congress salt bridge lakani oxidation side and reduction side maning lakani e cell do to ke haidi e right minus e left yare ko now let's come here koina khange kai hana electrochemical series to dagi hydrogen hariba part to kaya thagiba 0.00 volt yai ko hydrogen gi part to kai haba go to 0.00 volt magi kanano e not cell puthuk matam 0.0 0 volt tagi ham. What do we mean by standard hydrogen electrode? Have a port se hoji kamina ase. Standard hydrogen electrode ni ko sida representation hydrogen electrode se kai kai yawgani ba sidagi hydrogen pass togani sidana platinum machina yawgani last time on the use together electrolytes na ICL. Electrode any use of the electrode any use of sadis kana no among hydrogen will be treated as another electrode and another one is the platinum. So here see hydrogen electrode or standard hydrogen electrode SHE have a positive node. To measure electrode potential on the electrode ani dugi marakta standard electrode potential amadi khangada Duna to measure an electrode potential ama khangna buhonna matanda a half cell called standard hydrogen electrode ama legani kanana represent tawba by platinum hydrogen H plus aqueous ahum sina represent tawba means platinum H2 and H plus. Then it is assigned as a zero potential at all temperatures corresponding to the reaction. Reaction that correspond to the pull up na represent the that means sidana cell representation. This one is reaction. Sina mathaki the previous cell representation neba. Makada the cell reaction neba. So cell reaction sidana kai hare there is only the reaction between the hydrogen and hydrogen ion. Hydrogen ion ga hydrogen ga ani siki mata khatani reaction se and this platinum is so stable that it is not participating in any kind of reaction. Madi catalyst ki mathau to bakangu nebu aduna reaction that yaude So let's see here. Hydrogen have a pod set. In the previous slide, see slide this one. See here, hydrogen have a pod set. See electrode set or electrode potential set. It is 0.00 oika. Adu irakadi 0.00 oiwa pod set. It is known as to be standard ni hai zero potential hydra. Standard hydrogen electrode is considered as to have this zero potential. 0.00 that means zero potential level standard hydrogen electrode ni standard hydrogen electrode reaction then here it consists of standard hydrogen electrode have a positive have the Nicotic paragraphs. They are set platinum electrode. Platinum electrode and which is coated with the platinum black. Platinum hydride metals in the amuka so in this figure you can see standard hydrogen electrode ni hydrogen gas. Hydrogen gas yaugani adu kana platinum black coated tawreba then sidamu ubu phange kai haina the electrode is dipped in an acidic solution. Acidic solution here you can see HCl solution hydrocida. So it is the acidic solution. Whole electrode that means platinum as well as hydrogen gas. Standard hydrogen electrode solution. So the electrode is deep in an acidic solution and pure hydrogen gas is passed through it. They pass through there is hole and see pass to hydrogen gas pass to syllabus as the pass of gravity through it as the bubbles. Gas it will evolve as the gas or bubbles or in the form the lakani buka stagi junction bubbles or the then the pressure of hydrogen gas is 1 bar. Hydrogen gas ki saishida pressure se 1 bar ni 1 bar and the concentration of the hydrogen ions is 1 molar that means 1.0 molar so sidai kai khangi koina standard hydrogen electrode ama form to matam sida kai hydrogen gas as well as platinum black. Platinum metal ama changani hydrogen gas changani then the solution acidic solution ama changani acidic solution se hydrogen ion concentration ki chance se 1 molar and that of the hydrogen gas to give pressure it will be 1 bar then pressure magi concentration khange ko concentration se 1 molar oi pressure so 1 bar oi it is all unity 1 ngak to idra then amasu khange koina kai khange magi electric potential se kya ne haba it is 0.00 volt chumi ko electrochemical series today khangma ngamre ba koina then if the standard electrode be the left hand cell standard electrode sin ne left hand cell ne lower seba that means karamba anode cell ko anode cell ne low taragadi and its electric potential is 0 ne low ragadi kai lakto ba e cell gi value se e right ka manarakani haba yare ko e cell gi value se e right ka manarakani maramdi e cell da e left hana haribo pot se kana oya anode ke side to ne ba so here sigi side se ge khoi kai khangi yung e cell equal to e right minus e left see haba sida kai hare mo e right minus 0 equal to e not cell is equal to e right yare ko e left se 0 managra di e right katanga hauredna e cell se kana manare di e right ka mane hab yarba so akoina standard hydrogen electrode have matam sida kai khana doba e cell have se e right ka managani normally the standard hydrogen electrode hariba pot sigi e cell gi value se it is 0.00 volt oigrabani na pot se kai warani only the cathode hariba poto or the cathode to the thoiba e right reaction do or e value do electric potential of the cathode will be taken as e cell when logani have so the standard hydrogen electrode is also known as what mamin se kai kawe reversible electrode kai no it can be taken as anode on low CI, cathode on low CI. So it can be act as both the cathode and anode high. Hoji, for example, if we take E right as the standard hydrogen electrodes in low seba, I target the E right check 0 check hiniba. Aduga E cell give second hamanaba, E left command. So according to these, akoina kai gumba cell ama electric potential khang the pot ama Holo Hareko, Aduda, electrode potential, Akamba, standard hydrogen electrodes used already, Nakan Amasi Kaichakini, 0 chekrani, and we can calculate or we can obtain or measure the electrode cell of another left out electrode. Electrode to give potential, cell potential to calculate we are going to have. So this is the application for the standard hydrogen electrode, and again, let's go to the another slide. This is the most important equation for this chapter. This is the important equation. Have the equation. See the so calculate we are E cell, E not cell, calculate we are then. So here for the general electrode reaction, malore kay hana Mn plus aqueous plus N electron gives M. That means see that the river pot it is reduction. Electrons have laga masse solid form the phanghala ineba. That means it undergoes reduction. Reduction half cell ni low reaction se. So reduction low re. Then electric potential at any concentration measured with respect to the standard hydrogen electrode. Standard hydrogen electrode have a reduction low reduction another kai to a high oxidation. Kai to eba duga amadana cathode reduction to AI. Yareko, adu yakidi shida reduction. Lawi shakai gino have a question of malapra. Shida reduction like shakai high. Standard hydrogen electrode amalawi high with respect to standard hydrogen electrode. That means standard hydrogen electrode to left cell have the anode ni hello. Anode ni hello ready. Madi 0 chakra already 0 chakra. Madi 0 chakra nina there is no value and we consider only the reduction half cell. Anode takai to a high. In anode it is oxidation. In cathode it is reduction. Adu agadi anode oxidation to aga cathode reduction to e. So we are considering the reaction for the cathode. Cathode to reduction adu to never consider to say. Now here electrode potential ama calculate tabo matanda changi basi kana no sida high E not electrode standard electrode potential duni ko changi se sida so sida E cell buthoke harigadi standard electrode potential changi kana toroga buthoka it is given by E not cell minus RT R sina kana real gas constant, T sina kana temperature, that is absolute temperature duni lawise. Then N sina number of ions. Kaigumba reaction ang pitaragadi or kaigumba compound ang pitaragadi kaya ba ions na buto ise how many number of ions and buto pra o buto pra adu duni ko. Then F is the Faraday constant ni. Then sida ln hai se logarithm ni ko hotor se logarithm of concentration of m divided by concentration of mn plus. That means ako na class 11 na kangre kaigumba sumay na third bracket. This is meant to be the concentration of the element or concentration of the atom present inside this bracket. Yari ko. Sige, bracket sina tayo se. Kay term na haba? Concentration terms. Yari ko. So, concentration term ni haba sina udli se. So, if kay gumba concentration of M say have the mathakali report say sina 1 gamana magadi kay oy ni ba 1 gamana magadi E naught Mn plus M minus RT by NF logarithm of 1 by Mn plus concentration gamana kani hab ngari ko say khani se khona R se kanya ba real gas constant or gas constant having the value of 8.314 and F have a port se kay no ba Faraday constant magi value na 96487 sige value se na tabida 96500 coulomb per mole. Sige value se superior one. Sometimes we can use this one and sometimes we can use this one. Sige po sa ko nakadai decision na gani Gibbs free energy and molar conductivity hana mamangi chapter da yaw ke bado adudadi we use this value. Sige value se decision na ko Gibbs free energy ka molar conductivity ka or specific conductivity ka or ionic conductance ka miyam na igre ko adugi relation to the D. We use this one 96500 season book. But for this Nernst equation, they have provided us this value. That means 96487. So value se use to have. Then temperature se absolute temperature ni kaida on ba Kelvin on ba. We are not using the calculation using this degree Celsius. Degree Celsius lo de ko Kelvin do hot padunila we say. And this Mn plus has no concentration of the species Mn plus if there is M concentration of M high targeted concentration of the species M. Now let's hear application of Nernst equation. Nernst equation se kai decision nagadagi have duni ko. First, single electrode reduction to oxidation potential at any conditions. Calculate tawdo ni kaino calculate tawdo siya electrode potential. Karang batabo electrode potential na reduction hydra. That means when we consider the Nernst equation is low ba. Season na dora buka. Adu edagadi adu da ko na ahan bada khali siya. Standard hydrogen electrode amadi yawre hen logani ba. Yare ko. Standard hydrogen electrode amadi yawre hen logde siya kay we considered another reaction say oxidation say standard hydrogen electrode to thokre. Magi value se 0 igren lauri ne ba aduga amadu puthokna bu hona ne ba yai ko aduna reduction half cell gi electrode se puthokna bu hona ba matamda we can use Nernst equation. Then to oxidation potentials in any condition amma hekta da calculate to ngamdra ba adu regadi we are going to use this Nernst equation. Then standard electrode potential puthokpa yani hare. We have already seen it. If there is standard hydrogen electrode taragadi, that means hydrogen electrode to magadi standard electrode potential to lairani. Then comparing the relative ability as a reductive or oxidative agent. Kay standard hydrogen electrode season aragadi reduction kanan thoino oxidation kanan thoino ko magi electrode cell do khangdena cha adu already relative ability amadi khangdena ba kayamna reduction to anbangami kayam oxidation to anbangami ko inot cell se khangtari khangdena cha adumana compare to busi halakani ba mathang sum akoina reduction cell oxidation cell amaki butori ha si ko adu already cell ani dugi comparison to yarakatra yarakani chumi ko adumana compare to yarakani haba amana reduction han haba amana oxidation mo halakpa adumana compare to matanda sasa taroja that's the thing. Then binding the feasibility of the combination of such single electrodes to produce kai high electric potential. Kai high electric potential put by natra. Kai do na binding with visibility of combination of such single electrode. Single electrode may absent of one number since a puzzle like electrons transfer to electricity generator we are yarojanic then EMF of the electrochemical cell. Nasamata the standard electrode cell putupunga may high taragadi EMF of the cells of putupu yagani chumika. Then unknown ionic concentration. Aquina matata Sida Yango Matanda Kai Hai. Sige Potse. Ionic concentration Yaudra. Ionic concentration Yauramina. We can also find out the unknown ionic concentration. Ionic concentration putupu yaganiba. Then the pH of the solution. pH of the solution hadikaina. For example, if we say pH habumatanda hydronium ion concentration used out if we consider this standard hydrogen electrode labumatanda hydrogen ion concentration yaudra, that is H plus. See how we call H plus yabunina. We can also find out the pH of the solution or the concentration of the solution. Find out the pH compulsory find out to be ani duni. So the pH of the solution and solubility of the sparingly soluble salts. What do you mean by the sparingly soluble salts? Sparingly high targeted lightly soluble oibamanba oidi oidaba adugumba singdugi maramdasu kone khambangani solubility se test we ani habagumani ko. Then by Nernst equations might arani. Then last point hai kahana subchal lag haba chini ko sa hai sir. Nernst equation is often used to calculate cell potential of the electrochemical cell. Electrochemical cell gi cell potential calculate at any given temperature, pressure, reactant concentration. Concentration ama hekto oisanu, pressure oisanu, temperature oisanu. Aduda kay daw na buhanay ba? Nernst equation na calculate daw na ba? Then the equation was introduced by German chemist Walter Hermann Nernst. Nernst equation hariba pod si kanana putuki hai taragadi the chemist German chemist oriba Nernst hariba miyoshina putuki bani hab. So it is all about the Nernst equation. Nernst equation the most important thing and the most often used application for the Nernst equation is to calculate cell potential, standard potential, cell potential cell potential then let's see. Equilibrium constant reaction rate or chemical kinetics equilibrium constant habasiga standard electrode potential habasiga anisiga relation kai hana lagi yengsi ko kai hai akoi gi electrode cell da akoi gi let's say reaction amma laire red hana red reaction red to K A B B Sumaya tawgibado ninjing ko red law da. Sige red law sila pakan si dagi kay lai sige po sila chemical kinetics sa tamgibado ni ko. So sila K hariba po si kay no. This K is known as the equilibrium constant, reaction constant or equilibrium constant niba. Kaya nga si E naught cell is equal to 2.303 RTNF. Have log of Kc. See the Kc high reports the equilibrium constant K analysis. So see the yaw river K high reports. This is the equilibrium constant. Reaction among equilibrium constant. So the E naught cell equal to 2.303 RT divided by NF into log of Kc. It will be again equal to the log say. Fazana laura matunda RT ki value R and F ki value se loy hap chilakanda sige isna standard ni en lawe ko aduga 0.059 divided by N log Kc. Yare ko. So that Kc has a equilibrium constant ni E naught cell has standard electrode potential ni. Aduna ako nakhangise kay no nasai ki standard electrode potential haba siga equilibrium constant haba siga relation na masagali kay hana E naught cell equal to 0.059 divided by N log of Kc. sida kc hariba potsina equilibrium constant ni ko adugi e naught cell haisina standard electropotential. So this is the relation do ni ko kana kana imarakta standard electropotential and equilibrium constant. Now next ko hoji yeng do se kaina Gibbs free energy or Gibbs energy change have a siga EMF of the cell ka ani sigi marakta relation laiba ko sida laiba reaction se relation se sigi relation sida NF hydra sigi F se Nernst equation na sa use to give F ki value do adu nataba 96500 hariba sigi value se use to yai ko sida de ko. So let's see here commonly pinomabani ki relation se yeng si ko. Then reversible work done by a galvanic cell is equal to a decrease in a Gibbs free energy. Decrease in the Gibbs free energy, and therefore if the EMF of the cell is E oraba and NF is the amount of the charge passed over charge ki masing oraba, then Gibbs free energy na delta RG se oraba. Do di delta RG hariba pot siga minus NFE cell hariba siga managani hariba. Kay hay no sa karigumba reversible work ama piraba. That means akon hay karigumba electrochemical cell ama laitar kadi magi current direction of the current tuga direction of the electron tuga ko opposite chatna ni hai chumi ko opposite chatna ram ni na kai orani opposite chatna re doi target reversible work done su yadro yai ko. That means electron sina current ki direction na chatpa current sina electron ki direction na chalaba adu di reverse hoja reverse hoy. So adu gi matam do da sida galvanic cell amagi pot se reversible work done se kanaga manarba is equal to decrease in the Gibbs free energy. Gibbs free energy on a mag kita pot to manarba and kanaga mo. Therefore EMF of the cell se kanaga manani ba E and NF ka manar ka ni haba yare ko E and F ka do tari Gibbs free energy se kanaga manado na NF ka E cell ka adugi negative value do aduga manane free energy hamne mangi do na tra aduna mama negative line ni ko. Then if the concentration of all the reacting spaces is unity sai shida kai gumba E cell se puto gumba tanda ko reacting spaces myam se loy na mak sa 1 ba is unity. That means the yariba number of ions se 1 ni haraba ko adu erdi kai oni ba it will be termed as sigi mathaki som the pd reaction se sigi reaction se E cell ki value se kai lakba minus NF E naught cell manani minus NF E naught cell mathak the pd posega sigi posega yena watan the E cell ki value se sigi manani such that equilibrium constant ka Gibbs free energy ka ani sigi relation da. So Gibbs free energy is equal to minus RT ln K ka manani sida K hasina equilibrium constant minus delta RG naught hasina Gibbs free energy yare ko. Now here we come to new topic that is conductance. Akoy na hae Ohm's law gi matung inna karigumba kai heba resistance la daga di resistivity lai conductor lai rambagi conductance lai ni conductance lai daga di conductivity su lakani chimi ko. Aduna let's see what happens here into the conductance habu karino habu kumai lakhi habu do yengasi ko. So conductance in electrolytic solution amagi conductance kamai hot kani. According to Ohm's law na haye R equal V equal to IR ko. Sidagi lakpani V equal to IR. Do R equal to V by I. Chumi ko V equal to IR means R equal to V by I. So R sina kind of resistance, V sina potential difference or volt ne handle obusu ya I sina current. Yare ko. Such that electrical resistance of any object kahaba electrical resistance of any object is directly proportional to kanagana. Directly proportional to its length and inversely proportional to its area of cross section. Area ga length ka inversely proportional oi haiba ko. That means R is directly proportional to L and inversely proportional to capital A. A is in the area of cross section or cross sectional area and L is in the length. Adu already R sigi marak sida lady ba proportionality constant se ko na rho lore. This rho is my ibusu ya woni ko. So this rho is the resistivity or the specific resistance. So rho is known as the resistivity or specific resistance. Magi units na ohm meter, and 1 ohm meter se kanaga maneba 100 ohm centimeter. 1 ohm centimeter se kanaga maneba mo 0.01 ohm meter managani haba. Now, makadis man pire. Specific resistance ni high grade rho sa. Now, inverse of resistance R is called conductance. What do we mean by conductance? Conductance haba po sikarino hangtali kayo diba? It is the inverse or reciprocal of resistance is known as conductance. That means G haba po si conductance o natrit tawdaragadi. It will be 1 by R. So the high say 1 by R is the conductance that is inverse or the reciprocal of the resistance is the conductance. Do you resistance ki formula de kay no matatupigre kay haina resistance equal to resistivity into L by A. Sige value si hapchila matunga kappa A by L hantay. What is kappa? Kappa habipot se kay no sidala ise. This kappa habipot se it is 1 by rho equal to kappa. Yari ko. Sige kappa se mo kay ni na pira. It is the conductivity. Yari ko. Kappa is the conductivity. Conductivity ni adamagi unit na kay haba Simon per centimeter or Simon per meter. So that means the inverse of resistance is the conductance and the inverse of the specific resistance is the conductivity. Haurak from sa kaday dagino adude conductor amagi resistance adude hauriaba kay haba the resistance haba pot si dagi kanala ebo ohms law gi value lai ko ohms law na kay hani v equal to r sidagi r se reduce re kay hana r equal to v by I simalere then kariguma electrical resistance layam taragadi asagi resistance se kay proportional oniba length of the wire to the proportional onani and it is inversely proportional with the area of cross section ka di stay kay khangunga me area of cross section duga oinaramni na proportionality sign jelok thona bai damata ko na proportionality constant na mahapi maming na rho kawi magi maming atopa na kay haba symbol gi maming with rho lay ko rho is known as the specific resistance or the resistivity specific resistance or resistivity hana like then koi na khange kai haina kai gumba there is conductance se kana haba it is the reciprocal or inverse of resistance ki inverse na taka reciprocal bo kina kai ko yaba conductance adudi reciprocal of the specific resistance or resistivity de kai or mani conductivity so these are the short things that we need to know kai khange du there resistance le rambana conductance le that means the inverse of the resistance is known as the conductance. And then, if there is resistivity, we have to know where is conductivity. Conductivity the inverse of the resistivity is the conductivity. Now here, specific resistance kay holi ohm meter dagi oli ko magi unit sa ohm meter neba. Then conductance kiti kay oli Simon natraga na mo or per ohm. Duga conductivity de kay holi ba Simon per centimeter or Simon per meter. Then conductivity of the material se kay no hay taraga di. The conductivity of the material is its conductance. Conductance ni when it is 1 meter long aduga area of cross section sina 1 meter square oba matamda layga daw riba magi conductance to adugo kina kay ko ba it is known as the conductivity. So the conductivity is the conductance of the material when the material is 1 centimeter long. 1 meter long. When the substance or the material is 1 meter long and its area of cross section is 1 meter square. Now let's see another slide. Conductors conductors those substances or those materials which can conduct electricity in which the charge can pass. Sina charge adu already conductors have a port sida so makhala khara khaitoga lei kana no yingasi ko. So let's see here conductors matamda kana orani Conductors means those substances which can conduct electricity. Conductor na makhal ani suri. Kana ne haba. First one is the metallic conductor, another one is the electrolytic conductor. Metallic conductor haiba matamdudi metals kuding maksahara ni. Metals kuding makhai tari karamba electronic conductor hana kawe. Karigino we know metals can lose electron. Kai form tong na ba cation form tong na ba. Hai kwa ithoksi hapit na ningjing na ba kai haba metals lost electron. Kay form tong na ba? To form cation. Chumi ko, adu edi kay haba electronic high basigi logic ti kay na. Metal singsina electron loss tawraga electricity puthori or conductawi. Ko adu na mo se electronic conductor hane kawe metallic conductor sing ko. Then what about this electrolytic conductors or electrolytes hariba ko sidi kamai ta ba mo shu ions produced awi karam matamda when there is the electricity phangaba source tagi current ama phangaba aduedi the electrolytes gets dissociate itself into ionic form yai ko. Copper sulfate ana lagpa matamda kaitharani kaida copper 2 plus and sulfate 2 minus. So minus kaidra kai ko adu edi ionic oidra maso ionic ni amana electronic ni means electrolytes or electrolytic conductors are ionic conductors and metallic conductors are known as electronic conductors because they can lose electrons. Electron loss to banina electronic hai baniya ba yai ko electrolytic hai se kai no ha matam sida madi kai no electrolyte ni electrolytic current kana kai gani only when there is supply of electricity. Kay gumamao na source of energy ang pidra ba adoy target supply to bungam de ba gantay ko aduna source of energy to pidra matunda makaitharani kay form na two forms that is ionic form ani anion and cation ani the form to kan ko. Now we have known about the conductors. Conductor ni maran khangre. Now what about insulator? Insulator di kay no hari. Insulators are those substances which cannot conduct electricity or which do not conduct electricity. Electricity conduct to ngam daba electrolyte oy ba but electricity conduct to ngam daba electrolyte khara su lay ba. Adugumba electrolyte to su kay kawe ba non conductor electrolyte or non-conducting electrolyte hai moina ko adubu insulator mu hek hairagati kay kawani ba those substances which cannot conduct electricity tare ko non-conducting electrolyte hai ba ki mohta karigumba electrolyte or any type of the substances which cannot conduct electricity is known as insulator. For example plastic kum hai se ko plastic kum basika dawa plastic kum basya ko electricity pass to bakanda electricity cannot pass into it. And sometimes you might have heard about it like karigumba may siyam de oitaraba natraga na current pharaga chakadabo oitaragadi khongtonga chatlu tai ko so that khongtonga chatlu or rubber ki khongtongo hai sikagina matamda that rubber or plastic is insulator ne ba moise ai ko electricity power chapangam deba aduna conductor nakramnina so that we can protect or we can prevent ourselves from getting the electric shock to phangdana be na rubber gi khungu or rubber gi chapal tumya ai ko now let's see here you might have also seen this electrician rubber ki gloves bu uramani ko that rubber gloves is preventing them to get shock or electric current ai ko electric current chopa de the electric current na chingdo adu nga thok na bai damak tane yai ko now let's see here conductors khangre insulator khangre adu di sometimes me the sulai ko character se nupi ki character su khar yawa nupa ki character su khar yawa marak laiba ko and sometimes me khara se yamna su phaba yamna su phataba mi lai ko adu khara bana marak sar oiba like phabu su man ba phatabu su man ba khara su phaba khara su phataba later, there are some types of the substances which acts like a conductor and sometimes it acts like insulator. Like I need to only label. The ani thonga lairabanina, this ani makse, character ani makse. For example, that means like insulator ki character so, conductor ki character so, ani maksi yawa. Ani makti yawa do kai kaudo ba? They are known as semiconductor. Semiconductor so here substances like silicon, doped silicon and gallium arsenide has a gallium ne arsenide ne smiley duniko ani se smile dop toraga punna form to mineral compound ama adu target adugumba pot se kai organi ba they will form a type of the substance known as semiconductor ko silicon, doped silicon, gallium and arsenic. Doped silicon habse dana silicon with gallium ka silicon ka arsenic ka chumana germanium ka yausalak pa germanium ka silicon ka kaina doped to gibagi thegna many you might have studied in a class 11 also adu report to bukai ko we have a is known as a semiconductor now semiconductor have a pole say it has the conductivity between the range of conductors and insulators. Conductor ka insulator ka ani dugi conductivity ke range ki marak tale raba. Sina insulator, sina conductor ne hai target ki sige ahang ni bom marak se sige pot se da ngasai ki insulator and conductor ki ahang bo pot se sila target it is the semiconductor. Semiconductor ni have then what about the superconductor? Semi hai target tangkai na tra insulator ki tangkai conductor ki tangkai. Character ani mutu tangkai yaw neba. Now what about super hai tari hendo na tra. So let's see here substances with zero resistivity resistance handa graba purana adu target kai korakani ba it will be known as the superconductivity har kani yai ko. So here or infinite conductivity superconductivity or infinite conductivity is known as zero resistivity labor ko kani zero resistivity those substances are known as a superconductivity. Superconductive substances and Korani or superconductors. Now, these are the factors which influences the electronic conductance. Electronic conductance depend let's see here. Point number 1 is nature and structure of the metal. Nature and structure of the metal. Structure duga metal dugi nature duga depend wani ba then atopana number of the valence electrons per atom nasagi akhoni yengako matamda n hana half kibudo ko that is number adugi number to just lani electrons have the current types of electrons valence electrons metallic electrons samagi electron cam lost away valence electron tra lost away so that is the main important thing in this electronic conductance have the electron lost of the valence electron is very important. Again, decrease with the increase of temperature high. Decrease of conductance with the increase of the temperature. Kaya temperature say increase the conductance say decrease in case of what? Electronic conductance. See na mga factors like next, this na ionic and electrolytic conductance. Ionic and electrolytic conductance have the conductance of the electricity. The conductance of electricity by ions. By ions. See the electrolytic conductance has electrolytic conductors. Electrolytic conductors. So the ionic or the electrolytic conductance is the conductance of electricity by ions present in the solution. Solution to the ions to now put conductance of electricity. So it's called the electrolytic or the ionic conductance. So conductance conductance or electrolytic ions. For example, if there is supply of the electricity supply to reko adudagi ion se kaireba ion do kairam ni na masana current se here flow lai duna tra dumaina ion se now electricity se conduct to horaba then at that time there will be ionic conductance legani hariko. Now here the conductivity of the electrolytic or ionic solution se or conductance se kaide depend tawani ba nature of the electrolyte. Like in the case of the electronic conductance da depend with the kai metal gi nature and concentration da or sida electrolytic is nature of the electrolyte depend with hai that is then size of the ions produced at their solvation na size of kai number of the valence electron depend on hai da chamana na so size of the ions and their number do the size of the ions has then their solvation ising the tumbangi cha ka kam yang dissociate tawi kam yang association taw ngam ha ba cha then next the concentration of the electrolyte masagi electrolyte ki concentration kyamuk like for example masi 1 molar ra 1.5 molar ra 0.5 molar ra my concentration depend on again nature of the solvent and its viscosity nature of the solvent hai tadi kai no if we consider a type of the liquid solution then there will be compulsorily liquid solvent yaw din cha solvent depend on kani have then viscosity has a flow of the solvent then ko depend on the that increases with increasing temperature akhona mamang da kai hai for the electronic conductance or conductivity there is decrease with the increase in the temperature increase the way matung in the conductance or decrease in case of the electronic conductance but in case of the ionic state increasing temperature increases the ionic conductance like okay so in the next class we are going to learn the measurement of the ionic conductance or the conductivity of the ionic solutions kamane measure tawada ke have we will do in the next class till then be safe we will recap it in the next class so let's meet again in the next class till then hoji phawa tawriba sing se ayambana mamut thana khamjona bagi damata phajana paminisi ko amuk haina su recap to minasi so bye bye